Today, the North Texas area shows very little resemblance to its appearance prior to development. The area consisted of vast grasslands covered by rolling hills, dissected by rivers, streams, and tributaries. Trees were present on the landscape, but in fewer quantities than are present today. The introduction of cattle grazing was the first major land use, followed by development of ranches, farms, cities, and sprawling suburbs. This study will look at how the climate has changed over the past century and if there is an association to the landscape alteration. The study area consists of Dallas, Texas, and areas to the east and north. The counties selected include a cross-section of urban, suburban, and rural land uses. The counties include Collin to the north, Dallas to the southwest, Delta, Hopkins, Hunt, Rains, and Rockwall. As water demands grew, groundwater supplies could no longer meet demand. The impoundment of rivers into reservoirs provided the simplest option to provide a clean and reliable water supply. Only in designated parks or federally protected lands will you see the approximate 5 to 10% of native grasslands which previously dominated the territory. Questions can be raised in regards to how the change of landscape has affected weather patterns and climate. The large reservoirs lose water to evaporation, which in turn will increase the humidity and atmosphere above and adjacent to those water bodies. Wind patterns are altered near the ground surface, around and above buildings and trees. The urban heat island effect prevents the air to cool in the evenings and nighttime as the absorbed heat is released from the concrete and asphalt surfaces. As storms build, how does this increased temperature coupled with the increased humidity affect the quantity of rainfall and the location where it falls? This video will look at those questions across the 7-county area of North Texas. The temperature and precipitation data between the 7 counties showed very similar patterns. Overall, the temperature and precipitation rates were increasing from 1901 through 2018. For all 7 counties, the pattern showed an inverse relationship, except for the final 2 data sets, 2010 and 2018. Both of the final 2 decades showed similar increasing patterns. By the end of the current decade, these 2 points on the graph could end up being even closer, as 2019 has had above average rainfall and below average temperatures. As all temperature and precipitation graphs showed nearly identical patterns, the presence of reservoirs does not appear to have impacted the climate overall. Humidity data was not available for the area, which would have been useful in comparing areas within each county. The change of landscape could be associated with the increasing temperature and precipitation rates. Further examination of multiple counties across the state would be useful in determining if climatic changes observed in this study area also exist statewide. The climate change occurring in the North Texas area will require further attention on how water supplies are managed between flood events and droughts.